Okay, so this is part 2 of the Introduction to Fractions activity, and so we're going to start off with the applications here. There are 12 math majors, 15 science majors, 16 English majors. What fractional part of the students are math majors? So we're thinking of the part out of the whole, so the total that makes up the whole is going to go in the denominator. So if I've got 12 plus 15 plus 16, my total number of majors is, let's see, 31, 41, 42, 43 in the whole. And then the part is the math majors, so I have 12 math majors. That's going to go on the top. So 12 out of 43. What fractional part of the students aren't math majors? So we know 12 are math majors, so that must mean that 43 minus 12 are not math majors, and that gives us the 31. We also could have added 15 plus 16 to get that. So for the fraction, I've got part over whole, so 31 out of 43 are not math majors. What fractional part of the students are either math majors or science majors? So now I'm adding the math plus the science, so that's 12 plus 15, which is 27. So I get 27 as my part out of my whole, the total, which is 43. Okay, moving on to whole numbers. A fraction with the same number in the numerator and denominator is called a whole number. Draw a picture to represent 4 out of 4. So this tells me how many pieces I want to have. So I want to have 4 pieces. So you can draw any shape you want as long as there are 1, 2, 3, 4 pieces in there. And then the part is what I'm going to shade. So this is number of pieces. On the top is what I'm going to shade. And so I'm going to shade 4 out of 4 pieces, meaning I've shaded one whole piece, one whole shape. Why do we call this fraction a whole number? Because there's nothing left over, there's no remainder. The entire whole is shaded. And answers may vary there, just whatever you want to say to explain your picture. Okay, moving on to number 14. The following are pictures of proper fractions. So we've got 1/2 shaded, 2/3 shaded, 2/6 are shaded, 3/5 just means I need to draw something with 5 pieces. Not very creative here. I'm just going to go ahead and draw a nice rectangle with 1, 2, 3, 4, 5 pieces and shade 3 of them. For 3/5. For the proper fractions, how does the numerator compare to the denominator? Well, in all of them, the numerator is smaller than the denominator. And they want to know, are proper fractions larger or smaller than 1? Well, in all of these cases, I see that I have not shaded the entire thing, right? I have not shaded a whole shape, so they must be smaller than 1. Okay, moving on to improper fractions. So the following are examples of improper fractions. Let's go ahead and draw some pictures. So taking a look here, 7 out of 5. So 5, we have 5 pieces in each shape because of the fifths. So remember, that's the number of pieces in the whole, and I've shaded 7 of them. Here there's 5 shaded, and it's split into fourths, so and so on. So for 15/4, well, I know I'm going to have to be dividing my objects or my shapes into 4 pieces, but I need to shade 15 of them, so I'm going to probably need a few of these drawn. Right, even if I shade all of these so far, I've got 4, 8, 12 shaded, so I'm still going to need one more drawn. So this is 12 so far that I've shaded. I'm going to go ahead and shade 13, 14, 15. So 3 more are shaded for a total of 15 that are shaded. 3/2, so I know I'm going to be dividing into 2. Let's draw a couple of those, and I just want to shade 3 of them. Okay, for the improper fractions above, how does the numerator compare to the denominator? Well, in all of them, the numerator is actually larger than the denominator. Are improper fractions larger or smaller than 1? Well, I definitely larger, right? I have one whole thing shaded plus some extra. In this case, I have 3 holes shaded plus some extra, so it's definitely larger than 1. Okay. Following are examples of mixed numbers. Draw pictures of the remaining 2 mixed numbers. Okay, so it looks like I have divided into fourths. So I'm going to start by making some split into fourths. But I know that I have 3 holes that have been shaded. So I'm going to go ahead and start just shading them. That's 2 holes that I've shaded so far of my fourths. Let me do one more. So I've got 3 holes that are shaded. And then for my last one, still divided into fourths, it looks like I only want to have 3 of them shaded. So you might notice this is actually the same picture as what we have up here for 15 fourths. So 3 3/4 is the same thing as 15 fourths. Similarly, 1 1/2, okay, so I want to divide it into 2s. I have 1 hole shaded, and then just 1 extra here, and that's the same as 3/2. What kind of fraction, proper or improper, is next to the whole number? Well, these are all the numerator being less than the denominator, right? So what kind of fraction is that? It's a proper fraction. Okay, number 22, and we just observed that the improper fractions and the mixed numbers all have the same shading. It's just 2 different ways of writing it. I think in real life, we would see it written as a mixed number. You would never see a recipe that calls for 15 fourths cups of flour, right? You would see it as 3 3/4 cups of flour. So mixed numbers come up way more in real life, but we'll see in math, improper fractions are a little bit easier to put into a calculator and do math with. All right, moving on to the next page. This actually gives us a process to convert. So they tell us to switch from a mixed number to an improper fraction. You multiply the whole number by the denominator, take that product, and you add the amount in the numerator to it. And that's going to give you the numerator of your improper fraction. Your denominator is going to stay the same. Questions 23 through 25 are a little bit tricky to answer in words. So if you skip those and just want to go to the math, I can understand that. I myself had a hard time trying to explain it. So why do we multiply the whole number to the amount in the denominator? Maybe think back to the picture to see that. So the whole number tells us the number of holes that have been shaded in. And remember, the denominator tells us how many pieces there are. So it's a way of finding the total number of pieces in the holes. Okay. Why do we add the product of the whole number in the denominator to the amount in the numerator? Well, we still need to include any of the pieces that were left over that didn't make up a whole. So like this 1 extra piece, right, would get added on. So this will just include any leftover pieces. Why does the number in the denominator stay the same? Well, remember, this is still cut into fifths, right? That's not changing, so the number of pieces in each hole is staying the same. Okay. So now that we understand the process, let's go ahead and use our calculator to figure out these 26 and 27. So, I mean, you can use what we just learned up here, 1 times 8 plus 3 to get you 11, or on a scientific calculator, we have this button here. You just type in a fraction 1, fraction button 3, fraction button 8, and that's going to be 1 3/8. And then I can go ahead and just use second and switch it, hit the fraction button again, and that's going to switch it to an improper fraction form. So that gives me 11/8. Similarly, 5 and 4/9, so 5, fraction button 4, fraction button 9, and then I can switch that over to an improper fraction, so I get 49/9. And that's the same as multiplying 5 times 9 plus 4 and adding the 4. So, oh, I think they wanted us to do it both ways, so let's go ahead and just show that real quick. That would give me the 49 that I got on the top, 5 times 9 plus 4, and over here I would do the 1 times 8 plus 3 to get the 11 that I went ahead and put on the top. Okay. Next page, last page, mixed numbers to improper fractions. So this is just reversing the process. So they want to know, why do we divide the amount in the numerator by the amount in the denominator? So that's going to be the step 1 up here, right? You take the amount in your numerator. So if we had 11/5, we take that and divide it by the denominator. That's just going to find out how many holes we have shaded, right? Or how many whole parts we have. So like in this case, we ended up with 2 whole parts that were shaded. Why does the remainder become the numerator in the mixed number? Well, that's the leftover parts. So whatever's remaining is leftover. It doesn't make up a whole, so it's the leftover pieces. And number 30, why does the denominator stay the same? Okay, this is the same as the last page, right? The number of pieces in each hole is not changing. So for these questions, kind of like the last page, describing the process is tricky. Answers may vary. How detailed you want to get is up to you. This is personally how I think of it, but again, you might have different answers here. Now, let's go ahead and actually do the math. So convert to a mixed number, so we're going to divide. You just want to take 4 divided by 3. So, well, I don't know if we want to just let's try it on the calculator real quick. I mean, you could do it, 4 divided by 3, but if you do it like this on your calculator, that's going to give you a decimal, so that's not going to work for me. So you have a choice of try to do long division, or like they had up here, or we're okay with you at least using the calculator to check. If not, help with the division. Okay, so if we were to do the long division, 3 goes into 4 one time. Multiply down, subtract, carry the 1. So I have a remainder of 1. So I'd end up with 1 1/3. And we haven't done a lot of long division. Actually, I don't think we've done any long division in this class, so it's okay if you want to go ahead and just use your calculator to help. I'm fine with that. So I do 4 fraction button thirds, and then just do that conversion, second fraction button, and that's going to give me 1 1/3. So that checks out. 41/7, similarly, if you want to just go ahead and do that in your calculator, 41 fraction button 7, convert that over, and I get 5 6/7. That would be the same as if I did long division, divide and figure out your remainder. Okay, I think that, oh gosh, that's not quite it. One more page, this is a long activity. Okay, so practice. Your aunt brings out a tray of brownies. Your uncle eats 2/5 of the tray. Shade the part that represents 2/5. Okay, this is just practice. So we've got 2/5. The next time she makes brownies, your aunt cuts the pieces smaller, so there will be more to go around. Your uncle eats 8/20 of the tray. He's not getting tricked by those smaller pieces. He's like, I'm just going to eat more of those brownies. So we shaded 8. Okay, but notice it's still the same amount of brownies, right? He just adjusted and 8 more pieces to make sure he's still got just as much brownie. Notice that 2/5 and 8/20 are equal because they represent the same area. So to get an equivalent fraction, we multiply the numerator and the denominator by the same number, and that's going to work. So in this case, 2 times 4 would give me 8, 5 times 4 gives me 20. And so these 2/5 and 8/20 are equivalent fractions. Explain why multiplying 4/4 didn't change. Well, what is 4 over 4? 4 over 4 is just equal to 1, right? So we really just multiplied by a really fancy 1. 3/5, we want to get that as a denominator with 50. So let's think about what can we multiply top and bottom by to get 50. 5 times 10 is 50, so we'd have to do 3 times 10, which gives me 30. So 30 out of 50. Let's try to do the same thing, but 3/5 with a denominator of 30. So what are we going to multiply by to get to 30? So look at the denominator as your clue. So 5 times what number gives me 30? 5 times 6 gives me 30, so I get 3 times 6, which is 18. So whatever you multiply here on the denominator, you have to multiply on the numerator. So I get 18/30ths, and that is equivalent. Alright, and that's it for this activity. We made it.